welcome to this class. And in this class, I want to teach you about bitwise operators. Okay, they are like bit level operators. Solidity actually allows you to do bit level operations that has to do with binary operations, comparisons. It's almost like the logical and not and all that we've done previously, the logical operators, but this is at the bit level. And you will understand this, me saying it, if I don't show you by example how it works, because these operators aren't frequently being used, in your day-to-day smart contract development, but it's still vital that you should have some knowledge about it. So for example, let's get into the code. We have unsigned integer. We use 16 because these values are really small. So your unsigned integer 16, and then we call this is public, of course, call this A, and then we assign it 10, and then we do the same, assign this 20 for B, and the first, those are the value. So we have AND, which basically says A and B. So I'm going to show you what they actually how they operate on the result. Let's say OR. For OR we have A or B, and then we have XOR, which is A caret sign B, and then we'll have left shift, right shift. Let me show you that. So for left shift we have A left shift B, okay, and then for let's delete this. All right, so duplicating this for right shift. These are different operators of this bit level. So we have right shift, and then we have not. So this hand not is represented just like a tilde. That's a sign for a not called tilde. And then, so these are various operators of a bit level values, operations. So let's compile this. By compiling this, we deploy. So A is equal to what, 10, and B is equal to what, 20, just like we have them here. So if you add these two operations, A and B, because A is less than B, it's returning 0. What if I make A 30 and compile and deploy? So let's check that out. A and B. See now, A it returned the lowest value there, even though A is greater than what, B. Okay, so A is 30 and it choose to what, return 20, because okay, now one more thing, let's make them 20 and see what happens before we make our conclusion there. So let's click on that. So it returns 20. So basically, when you're comparing two values, the AND operator always return the smallest one. All right, the smallest value, that it's what it's returned, from what we just seen here. And to make everything even, let's change this to 40, and let's see again how that operator works. Like I told you, these operators are not frequently being used on the day-to-day runnings. You see these 20 to 40, because 20 is less than 40. It didn't return 20, which is the lesser one. It returns 0. So you should understand that this AND in this bit level operation, when value A is less than value B, it will what? Return 0. When value A is equal to value B, it is going to return what? The value A. When value A is equal to what? Is greater than value B, it's going to return value B, so it returns the list. That is what you should know about the AND operator. So let's check the OR operator to do that. Okay, so let's check the OR. Okay, the OR basically adds the two values together and return it to you. So what if I now have, I make this one smaller, let's say 10, and the other one is 20. A is 10 and B is A is 20 and B is 10. So let's check what OR is all about. So it still adds them together. So this OR just basically, which is here, it just basically adds these two values, these two integers together and returns it as the result. So when you're performing bit level operation, take note of that. So what about, let me take this, okay, and then have to deploy again. What about for XOR exclusive, which is this exclusive OR? So it still returns an addition of both value, which is this A plus, which is 10 plus what? 20, that is 30. What if I make this 20 and make this one 10? Save that, compile and deploy, check it out, the OR. So basically there seems to be no difference between how this both operates. They operate the same, if not exactly, but I believe that must be some level of difference between them. Okay, and let's say we make this first value 0 and then the second one 10, and let's compile and see what we have with that OR. So this is all. So we have, click on this, it returns 10. So basically it's always the addition of the both of them. So now the next thing I want to show you is this not, goes insane. But for some reason it just make a crap of the number. I can't even explain how this is resulting in this particular listen, but that is what not does for you. Like I say, this isn't really something that you'll be using in your day-to-day operations, because they are not often used for the regular use cases. All right, so this is left shift return 0, right shift return 0. What if I change this to 10 and change this to 20? Let's see how it works. So let's compile that, deploy, let's check, left shift return 0, right shift return 0. So let's increase this, say 20, and make this 10. Save and deploy. Let's see how the result is. Left shift returns an insane amount of number. Can't explain that either, and right shift returns 0. So like I said, I just needed to put this thing out there for you so that you know that they actually exist. Okay, and so you could do your own research on them, but quite often in most cases you will never see people using this particular thing in their programs. So that is it for the bit level operators. I mean, they are useless, but they have usefulness in various areas. Believe me, these things they have use, but for me, I don't normally use this in any of my coding or development purposes. So till next time, I wish you all the best.